Imagine that every time you go to the doctor, you get a small finger prick, and that resultant tiny droplet of blood is used to make 50 measurements in about 10 to 15 minutes, and the information is added to your digital health record. What we can do in technology is defined by our tools. And if we want new capabilities, new possibilities, we need to create new tools. Envision walking into a medical diagnostic lab such as this one at our local hospital, and you take this lab and shrink it down to a tiny chip. This is the scientific field of lab on a chip. Well, individual features on these microfluidic devices need to be about 100 microns or less. So how are microfluidic devices normally made? Well, usually they're fabricated in a clean room, one of those rooms where people run around in bunny suits, such as the BYU clean room that's shown here. In late 2012, I started to think about 3D printing as a possible method of doing this kind of fabrication. You need to be able to take a liquid precursor material like this yellowish liquid in this little tray and turn it into, using your 3D printer, some kind of a solid device with all kinds of structures in it. What we've done is taken this clean room, slow method of making microfluidic devices and turned it into a little small, in comparison, 3D printer that eliminates the huge cost of the clean room and allows you to make prints very quickly. We routinely do things in maybe 30 minutes, 20 minutes, 40 minutes, depending upon the device. And we can make very complex devices because it doesn't take any longer to do that. What's important is that you have faith in people, that they're basically good and smart, and if you give them tools, they'll do wonderful things with them. We are really excited to see the wonderful things that people will do with the new tool that we've created.